In the last class we started seeing two-dimensional arrays. The general syntax is like this. For one-dimensional array we had only one level of indexing, but here we have two level of indexing. Number of rows here, number of columns here. Okay, so this is a two-dimensional array of 3 rows and 4 columns. If I graphically represent that, if I create a two-dimensional array, this 3 indicates there are 3 rows. This is one row, this is second row, this is third row. Okay, and 4 columns. This is one row, one column, second column, third column, fourth column. But the indexing of the rows and columns, they start from 0. Row 0, row 1, row 2. Here column 0, column 1, column 2, column 3. So total 4 columns. Indexing starts from 0 and last indexing is 3. 0, 1, 2, 3. 4 columns. And row indexing starts from 0 again and row 0, row 1, row 2, total 3 rows. Total how many elements in this two-dimensional array? 3 into 4, 12 elements. If we want to access each cell or each element in the two-dimensional array, we have to apply a row index as well as a column index. So here row index value is 0, column index value is also 0. We get the first element in the two-dimensional array. Now by keeping row index same as 0 and changing column index to 1, I get the second element in the first row. Second element in the first row. Then third element in the first row. Fourth element in the first row. Now if I want to go to next row, I change the row index. Row index changed from 0 to 1. Column index is 0. So first element in the second row. Second element in the second row. Third element in the second row. Fourth element in the second row. Similarly, elements in the fourth row also we can third row also we can access. Okay, this is the memory visualization, the logical representation of the memory arrangement of a two-dimensional array. So previously it was linear. For one-dimensional array it was linear, just one line, no tabular form, one column or one row, whichever way you want to see it. Now it is not linear, it is non-linear, basically two dimension in the form of like a table. Okay, last class we saw how to initialize, compile time initialization is done. Here also two types of initializations are there, compile time initialization and runtime initialization. We just saw compile time initialization. I will not repeat that again. We can directly go to runtime initialization because that is what we are going to use practically. During execution, how we get the data from the user and initialize the array or store it in the array. Okay. Now, to access any element in this array, 12 elements are there in this array. 3 into 4, 12 elements. If I want to access any element, I need two indexing actually. One indexing for the rows and another indexing for the columns. Okay. So previously we used for linear array one indexing only, indexing variable I. Then we used for I is equal to, this is what we did. For linear arrays or one-dimensional arrays, only one level of indexing is there. So we used variable I for indexing and we stored, by varying the value of I, we stored element at each location in the array. The value at each element of the array or each location in the array. Now we have two dimension. For each dimension we need one indexing variable. So normally for row indexing we use I and column indexing we use j. And we use a simple for loop, no nested for loop, only one for loop. for one dimensional array. When we are migrating to two dimensional arrays, we will require nested loop. Nested loop. Okay. So this is the practical example of how to initialize a 3 by 4 array. A two-dimensional array of dimension 3 rows and 4 columns. I have two loops. One is the outer loop and one is the inner loop. The inner loop is used for storing a column or storing the elements in a row. Storing elements into a row. In a particular row. Storing elements into a particular row, we use the inner loop. So a particular row means what? Say row 0 I am choosing. If I am choosing row 0, I want to change the store the elements in these locations. For that, the index I need to change. I will probably take this diagram. I want to store elements in this row. For this row, what is the thing that is not changing? The row index is not changing, but column index is changing. So row index for this row is 0, but the column index is 1. Column indexes keep changing. For the first element, column index is 0. Second element, column index is 1, 2 and 3. Okay. So what we do is, using the inner loop, we are varying the column index and try to store elements in these values in these elements, array elements. So at that time, the row index remain constant. Only the column index is changed. Okay. Now if I want to populate the next row, what I do is, row index is increased to 1 and that remains same, but column index is again changed 0, 1, 2, 3. So throughout this row, the row index remains same, column index is increased from 0 to 3. So this is how this is achieved programmatically, is using a simple nested loop. Using a simple nested loop. Variable I is used for selecting a row. I is used for selecting a row. J is used for selecting a column. Okay, you have to clearly understand this, how it works. Then only you will be able to practically apply this concept in any program. Okay, so when we compare this one, first you have to understand clearly. Linear arrays, how we are initializing or storing elements into a one-dimensional array. How we are doing? We have only one level of indexing. The indexing variable is I. So when I is equal to 0, the first element is populated. When I is equal to 1, second element in the one-dimensional array is populated. Now since we have two dimensions, for each dimension we need to store we need to use two different indexing variables. So for selecting column we use the inner loop with the j as the indexing variable. For selecting row we use the outer loop and the variable is I. Indexing variable is I. Okay. So probably I'll take this example only directly into our program and try to build that. This one-dimensional array concept is clear to everybody, right? How we are scanning the elements. Then same simple for loop is used for accessing in the elements for processing it. Then displaying also we use the same one simple loop and one indexing variable. Now the scenario is changing. So I have uh, I have declared or created a two-dimensional array of 3 rows and 4 columns, and I have declared variable I for row indexing, variable j for column indexing. Okay. Now since I have only 3 rows, I put the loop like this: I is equal to 0, I less than 3. So first row the index value is 0, I value is 0. For second row I value is 1. Third row I value is going to be 2. Only 3 rows. And for column we are using the inner loop. Column selection we are using the inner loop. Remember I told that when we studied nested loop, for every iteration of the outer loop, the inner loop will execute all its iterations, right? So initially when I is equal to 0, let me see if it compiles. Looks like it is compiling. Yeah. So how this works, I will demonstrate now. uh, it is not asking for any elements, so I'm directly going to enter the elements here. Yeah. So initially we'll see the watch window. I'm here now. I'm here. I is equal to 0, I less than 3, I plus plus. Okay. So I is 0 now, and 0 less than 3 is true. We are going to enter into this loop because this condition is true. So now I is equal to 0 means we are going to populate the first row. I is equal to 0 for the first row of two-dimensional array. We are going to populate this row. For this row index value is 0 and column index value keep changing: 0, 1, 2 and 3. Now the inner loop is used for selecting the column. Okay. Now initially j is equal to 0 and 0 less than 4 is true. So we go into this loop. Now you see here I is equal to 0, j is equal to 0. Okay. That means when I am scanning an element a of 0, 0, a of 0, 0. What is a of 0, 0? The first element of the two-dimensional array. Okay. Now if I execute this, I have to enter the matrix value here. So already, yeah, I'll put set 1, 2. Directly I'm going to put it so that I don't need to keep coming back here. 3, 1, 2, 3, 4. First row, 4 elements. Second row, 5, 6, 7, 8. 5. Okay. No, it is, since I press enter, I'll have to enter it next time. So 4 elements directly I'm entering so that I don't need to come back again enter. First rows elements I'm directly entering. Now we'll go to the array. So this is row 0, row 1, row 2. And 1 is stored in, after executing this loop for one time, 1 is stored in A00. 0. I is equal to 0, j is also 0. I is equal to 0, j is also 0. A00, 1 is stored. So next element I am entering is 2. And we press here. Now 2 is read. 2 is taken into the program and stored in A01. I is 0, j is 1. So at A01, 2 is stored. I am not changing the row index, only column index is getting changed. Initially it was 0, now it is 1. Now next iteration, 3 is scanned and stored in A02. So if I go here, A02 is, so 3 is stored here in the array element A02. One more iteration, 4 is stored. Okay. Now j will be incremented to 4. Here j will be incremented to 4. 4 less than 4 is false. We will come out of the inner loop. Once we come out of the inner loop, there is no other statement. We will go to the outer loop, starting of the outer loop, because we were doing the first iteration of the outer loop, but we did all the iteration of the inner loop once. And what is the outcome? The first row is taken into the array, or first row of the matrix is stored into the array. 1, 2, 3, 4, they are stored into the array. Okay, now I will be incremented to 1. That means we are selecting the second row. When I is 0, we are selecting the first row, and we kept on changing the column index and stored the values. Now I is incremented to 1. That means we are selecting the second row and trying to store elements into the second row of the two-dimensional array. F7, I enter into the loop, because 1 less than 3 is 1, 1 less than 3 is true. So I enter, and I am going to execute this loop completely one more time, but I value is now 1. J value will be again reset to 0. Now I is having the value 1, j is having the value 0. That means A10 we are going to, the element to be stored in A10 we are going to read from the user. That means the element to be stored here. Now if I press, I have to go and enter the data here. So 5, 6, 7, 8 I have put 5, 6, 7, 8 for my second row of the two-dimensional array. If I press enter, you can see that 5, no, this I will close now, I will select the second row where index is 1. 5 is stored here. Now if I continue to execute, 6 is stored here, 7 is stored here, j value is 2, now j will be increased to 3, 8 is also stored. So A10, 5 is stored, A11, 6 is stored, A12, 7 is stored, A13, 8 is stored. A10, A11, first index is row index, A10, A11, A12, A13. In all these locations, data is stored. Second row is stored. Now I have to store the third row also. I value was previously 1, now it will be incremented to 2. 2 less than 3 is also true. So again we enter, and I value 2 is for the third row, and we are going to populate the third row now. And using j, the column index, we are going to store the elements in third row also. You have to understand this process very well. Now it is waiting for me to enter the third row. I will put say 1, 1, 1, 7, something like that. 4 elements are there. I will press enter, and this loop. So here first row is populated. Now second row is also populated. We are trying to populate the third row. 1 is already stored. 1, 1, 1, 7 are the integers I entered. First iteration of the inner loop is over. Again, second iteration of the inner loop, 1 is stored in A21. A21, 1 is stored. A22, 1 is stored. A23, 7 is stored. Now j is equal to 4. J is 3 here, but as soon as this here it will be incremented to 4. 4 less than 4 is false, will come out of the loop. Now I will be incremented to 3. 3 less than 3 is false, we will come out of the entire loop. So this is the input process for a two-dimensional array. We use a nested loop, and the outer loop is used for choosing the row, and inner loop is used for choosing the column within the chosen row. So first I equal to 0, first row is selected. We are going to select each column of first row and store the element at this location. Next time second row is selected, and we keep changing the column index and keep the elements in the second row. Store the elements in the second row. Later, third row is selected. When I is equal to 2, we store the elements in the third row by changing the column index. This is the process used for storing elements into a two-dimensional array. Okay. Is it clear how it happens? So here in watch window, an array A is there. If I expand that, I can see the columns. Column 0, column 1, column 2. If I expand that, I can see, row 0, row 1, row 2. If I expand that, in row 0, the columns I can see. Okay, even though it is not represented as a table, but we can imagine actually in row 0, all the columns. Again in row 1, all the columns. Row 2, all the columns. This is the process happening. So for a one-dimensional array, we had certain things. A one-dimensional array, it was relatively simpler. A simple for loop was enough to store elements or access each element and process it and print it. Now for a two-dimensional array, for storing the elements, for processing as well as displaying the values, we need nested loops, two-level nested looping. But it is pretty straightforward, the same pattern. You just need to understand this, what is happening. The outer loop for selecting the row and inner loop is for selecting the columns in each row. Columns in each row. Is it clear? Understanding this is very important to do many of the programs. Any doubt is there, you please ask me. Don't ask me whether this will be present for the first test or not. This will be definitely there for the second test. This is not there for the first test. Any question? Now what will change? This pattern is going to be the same. Either to store elements into the array, we are going to use only scanf ampersand aij. Since it is two-dimensional array, one element in the two-dimensional array, it requires both row index as well as column index. So when I do aij, I select one variable or one element of the two-dimensional array. If I want to put data, store data there, I have to use ampersand aij. Okay, so I will, and now what is going to change? Now I have created a matrix of 3 rows and 4 columns, 3 by 4 dimension, and I am hard coding 3 and 4. Instead of that, what we are going to practically do is, we are going to ask the user what is the dimension of the array. That is the only change. Instead of 3 and 4 here, some variable will come. Number of rows, number of columns. So what I can do is I'll declare 2 variables. So before that, I'll just show one more time the execution of this with the watch window. So in watch window, what we are seeing is in memory how it is stored, or in what values are stored in the memory when we are executing each statement. That's what we are. As of now, some random values are there. Some random values are there in each row. Okay, I'll replace I'll replace with the name array or ARR so that you distinguish. Yeah, I have to use modified here also. So ARR is the array. Each row, see array row 0, row 1, row 2. Here So okay, I is equal to 0, j is equal to 16, some random value, because we have not initialized I and j so far. We are just waiting to execute this statement. Then only I will be initialized to 0 and j will be initialized to 0 here. Okay, as of now in the two-dimensional array, some random values are there. Some random values are there. I want to store some proper data which I want to process. So I keep executing. So here I am going to enter first row elements. So 3 2 3 2. The inner loop is going to populate the first row now. Already 3 is populated since first scanf is already executed. One iteration of inner loop is already there done. We are in the second iteration of the inner loop. Now all the iteration of the inner loop for I equal to 0 is over. So first row is populated with 3 2 3 2. Now we have to populate the second row. For that we are proceeding. I will put 6 8 6 8. Maybe the third also I will directly put here, so that I don't need to 6 8 6 8 9 9 7 7. I press enter. Okay. Now second row is going to be populated. This is already populated. Second row 6 is already taken. This 6 is already taken. First 6. F7 F7 6 8 6 8. Now second row is populated. Now we are going to third. 9 is taken because I already kept that, I already entered the data, so it is keep reading that. Now second 9 is taken. 7 again 7. Now we come here, I becomes 3, 3 less than 3 is false, we go out of this loop. So all the elements which I entered here are here stored in the computer memory now. This I entered from the keyboard, now it is stored in the two-dimensional array. 3 2 3 2 6 8 6 8 6 8 6 8 9 9 7 7. Okay. Now if I want to display this back, what is that I need to do? Display the elements of the array back. What is that I need to do? Similar fashion, very similar fashion, I need to display, print. So instead of scanf, I have to use printf. Now I don't need to put ampersand because I am printing. I want one space to come after each element in a row. Okay, so I put a space here. Now after printing one row, this is going to print one entire row. Before printing the next row, I want the next row to come in a new line. So what I do is I print a slash n, simply a slash n I am going to print. Okay, other than that there is no change. So here I am scanning or reading the data into the two-dimensional array. Here I am printing the data into the two-dimensional array. From the two-dimensional array onto the screen. So to differentiate that, I will put a message here, printf the 2D array is. The 2D array is, maybe I'll put a slash n also to make it look nice. Okay, so whether it is compiling, what is missing? printf I have to use. Okay. Okay, now I'm going to execute without, not in debug mode, because this loop as well as this loop both are essentially same. The structure of the loop is same, so it is going to execute in the same fashion. Okay, for every iteration of the outer loop, the inner loop will be executed completely. So this is for displaying the elements of a two-dimensional array. So I'm going to directly execute it. I have to enter the elements 1 2 3 1 2 3 4, in fact, right? 1 2 3 4. Then second row Okay. No, yeah, something went wrong. What is that? Two-dimensional arrays. Let's see. Okay, I should not have put in single quotes. I put actually, I should be putting it in double quotes. By mistake, I put it in single quote because of that there was a runtime error. There was no compilation error. Single quote it's a character, but printf takes a string. The first argument to printf is a string, which should be in double quotes. So I should have put slash n in double quotes. That was the problem there. Now if I enter the elements, first row, second row, third row, the 2D array is exactly it is reproducing the array I entered. Okay, so this is how you display back the two-dimensional array. This is how you are going to read input into the two-dimensional array, and this is how you are going to display the two-dimensional array back. Okay, taking input. So normally we have three things: taking input, processing the data, then displaying the result back. Now if I want to process the data that I stored in this two-dimensional array, what should I do? I have to access each element or each value in that and apply some operation. So for that also the pattern of the loop is same. So I am going to process the data. Process the data. Okay. So I use the number of rows are same, number of columns are same. So my boundaries are same. Now instead of this statement, I will apply some operation. Okay. So let's apply our simple operation of doubling the element. So what I do is array ij. Now any element in the array here, when I am here, I will have a value, j will have a value. So if it is 0 0, I value 0, j value 0, that means first element of the array. So what I do is first element of the array equal to 2 into the existing value of the first element, 2 into a of ij. Simple operation I am doing. Every element in the array I am going to double and store in the same location of in the array. Every element in the array I am doubling it and store it in the same location. Now if I execute this, so this loop is going to select every element. This nested loop structure is going to select every element in the array. Now I just need to apply the logic or the processing part I want to apply on this. Okay. So if I execute, what could be the output? So my element first row, second row, third row. After the execution, every element is doubled. 1 2 3 4 became 2 4 6 8, then 5 6 7 8 became 10 12 14 16, and third row is also updated or doubled. All the elements in the array or all the elements of this matrix, this is actually a mathematical matrix. All the elements in the matrix is doubled. So this is the processing part. Okay. Now how can I make this program little bit generic? Now it will work only for 3 by 4 matrix. I need to enter all the elements, all the 12 elements. It will not work for 3 by 3 or 5 by 5, etc. So what I do is I will introduce two new variables, rows, cols. Rows for the number of rows in the matrix. Assume that we are storing a matrix. The maximum number of rows in the matrix, which this will be a user input. This also will be a user input. So how many rows are there in the matrix, how many columns are there in the matrix, I am going to ask the user to enter it. Okay. printf enter number of rows and columns. I'm going to scan the values. Scan of, they are integers, row value and column value, they are integers. I'm going to scan them. Ampersand rows calls. Now I need not have always 3 and 4. Instead of that, I am going to put rows here. The outer loop is for rows, inner loop is for calls. So whatever matrix user, dimension matrix user wants to enter, he can enter now. Okay, here also I am going to use rows and columns, calls. Rows and calls. This many rows, this many columns. Previously it was 3 and 4, so I directly put 3 and 4 here. Now I will not use that. My program I am making it more general and useful, applicable for matrices of different dimensions. Okay. Now, is there a potential problem? So, okay, I'll run this program. Yeah, there is a compilation error. I did not put closing bracket. Is there any other compilation error? I did not put semicolon here. Yeah, these are bound to happen and no need to worry about that as long as you are able to solve the compilation error. Okay. Now if I execute this, enter rows and columns, I am putting 2 by 3 now. Instead of 4 by 3 or 3 by 4, 2 by 3 I am putting. Okay. There is a problem again. Okay, I did not put ampersand here. In compilation that error did not show up, but I forgot to put ampersand here. Okay. Now I can put a message also. Enter the elements. Printf enter the elements. So matrix or array, whatever it is. Since is a two-dimensional array, we'll put it as matrix. So I'm going to execute now. Enter the number of rows and columns 2 and 3. 2 rows, 3 columns. Enter the elements. So now I know that I need to enter 6 elements. Because of that I'm going to enter 6 elements. In first row 3 elements, second row 3 elements. And in the processing part, the doubling of elements is done. Now 1, 2, 3, 4, 5, 6 has become 2, 4, 6, 8, 10, 12. So now this is a general program which will take any dimension matrix based on the user specification, store elements. We can input the matrix elements that will be stored in a two-dimensional array. Then all the elements will be doubled and displayed back. Now there is only one problem left. Since I am creating an array of 3 by 4, the maximum number of rows I can specify when I am executing, that is 3, and maximum number of row columns I can specify is 4. That's why when I executed, I entered 2 and 3 for rows and columns. Now if I want to enhance, I want to use sufficiently general size matrices, I can give a sufficient large number. Now I can, when I am executing, I can enter even 5 by 5 matrix, 3 by 4 matrix, 7 by 7 matrix, all those things I can enter, and it will be processed. Because the maximum number of rows I have specified here is 10. So up to 10 rows and 10 columns can be there in my actual matrix entered. When I am executing, the actual matrix entered, up to 10 rows and 10 columns can be there. But the elements utilized will be based on the actual values of rows and columns entered. That means even though this is a large two-dimensional array of 10 rows and 10 columns, if user is entering 5 by 6, we are only utilizing a part of that. One time I am executing, I am entering 5 by 6. So 5 rows, 6 columns. Another time I am entering 3 rows, 3 columns. Like that. So this is now a sufficiently general program. You can enter up to 10 by 10 dimension matrix, 10 by 10 dimension matrix starting from 1 by 1. So 1 by 3, 3 by 3, 4 by 4, 6 by any up to maximum 10 by 10 dimension matrix we can enter in this two dimensional array. Enter the input, process it and display back. So this is the complete program. Okay, with that we will stop. This will be the next assignment question. This will be next assignment question. If you want, you can take a snap. So how do I maybe take this things and all I'll remove so that it comes in single page. So this curly braces I can keep it here. So all my program will come in single page. Processing data also I'll remove. Yeah. So this will be your next assignment problem. With that we will stop here and